I was too busy decrashing Zoom. And with that, we will pass across to Pamela for her demos. Thank you.
Awesome. Thank you so much. So anytime, feel free to ask questions, jump in. I'm all about this being interactive, so feel free to just go ahead and ask questions throughout. So today, I was just going to go over, what are the two paths of building an IoT solution, and then do a workplace safety solution with the team. And so, and I was going to go into little parts of how built the solution, how it's ran. We'll also talk about deploying models on a camera device. So this is the AI dev kit. Let me know if some of you have seen this kit before. And then hopefully, let's all cross our fingers that my internet doesn't go down, because I am streaming this video and on Zoom and presenting. So we're just gonna cross my fingers, because I went pretty cheap on the internet here. So we'll see what happens. Okay, so I'm gonna go ahead and share my screen. And let me know if everyone can see everything.
Yep.
Okay, awesome. Thank you. So I want to make sure we don't spend too much time in slideware, but I always want to just kind of start off talking about building IoT solutions. And this is mostly because this is a question I get a lot, and especially when it's building IoT solutions with Azure. And so I just wanted to go through the two different paths of doing that, and what do we think about when we're thinking of end-to-end IoT solutions. Oh, and I'll move this little guy down. Okay, so I always start off with this slide, but this slide, I can see why it could be a little overwhelming, because it's just a list of a bunch of products. And but I really wanted to just kind of showcase that when you're building an end-to-end solution, there's actually a couple different entry points you can do. And I'm talking primarily for Azure, and we'll talk about all up IoT solutions that really kind of works with any cloud provider. But for this one, I'm going to go through the Azure IoT portfolio. And so those different entry points for building IoT solutions really kind of starts with the foundation, and what we consider, kind of the heart of our services, and which is our platform services. So the first thing is connecting those devices. So we do have the IoT at Edge device support. We have Azure Sphere. I know we just talked about Windows IoT earlier before we started the presentation. We have device SDKs, but really want to land here is that any device you have, we have a way to connect it to the cloud. And that's why you see a lot of different offerings in that area. So you're not just tied to, let's say, Azure Sphere. You have to buy this dedicated device in order to connect to Azure. And so that's really important to us. You could even use like free RTOS and connect to Azure, and not use Azure RTOS. So the goal here is just to explain, we really have an open platform for anyone to use. The second kind of that foundation is really the Azure services for IoT. I really kind of consider this like the Lego blocks, and I'll get into this in a moment, but this is where you have services like Azure IoT Hub, where you're connecting devices to the cloud, device provisioning service, where you're provisioning these devices. And I'm not gonna go too much in depth of all of these services right now, because I'll just be naming off products. But really the core here is to say, if you're trying to build a custom IoT solution, we have different products and services to help you build that end-to-end solution. And I have a nice image to kind of show how those products fit in there. But you can choose which products and services make sense for your solution. The next thing up is really Azure Digital Twins. Digital twins, it just makes it easy to model and interact with any physical environment and track the past and predict the future. We have Azure Digital Twins in preview right now. Definitely join our Ignite event next week because we will be doing some announcements there. So that's your little sneak peek on Ignite. And then the second entry point is really Azure IoT Central. And this is a fully managed application platform. And so let's dig into what all this stuff means. So building with our platform services. I mentioned before, these are kind of like Lego blocks, and every Azure or every IoT solution is different from each other because you have different industries, you have different use cases, you have different devices. But the main thing is that there's certain subsystems within an IoT solution. Let's just take Azure out of the equation at this moment, that helps build an IoT solution. So you have things, which I think I have, this is a better slide. You have things where you're actually connecting different devices. So you have edge devices, you have normal devices where you can connect directly to the cloud. And then you have insights, where that's where you can identify those patterns, you can create rules and alerts, but it's all gathering those insights. And then you have actions. And this is where you could do your business integration. So just giving you an example of things, insights, and actions. Things would be, let's say you work on a factory floor and you have a pick and place machine. And you have a device that's connected to your pick and place machine, where when the pick and place machine goes down, that device connects to the cloud and sends an alert or sends data up. And so you would actually have that device connected to a cloud gateway. And this could be any cloud gateway. For example, I have Azure IoT Hub, but AWS, Google, they all have some sort of cloud gateway to make it easier to connect to their cloud. So that's when you connect your device, and then you take the data, you do some stream processing, and you actually will sit there and gather insights from services like Azure Stream Analytics in order for you to identify those patterns. Another big part of an IoT solution is storage. So you could do warm path storage, where if you need the information right away and you need to do something with that data, you'll put it in that. There is cold path storage if you want to do long-term, if you have collecting data long-term and then you want to use it down the road. The goal here is saying that from that pick and place machine that has a device that's connected to it, it's sending data through a cloud gateway. You can process that data to say, hey, when, let's say, the pick and place machine goes down, it means nothing is running, send an alert, which is when you do action. And that's where the business integration comes in. So you can send an alert to a service worker. So that's kind of a really high level example. But the reason why I wanted to show this is that there's all of these products and services that you can use to build an IoT solution. And that even though there's tons of IoT solutions out there, there is core elements of each IoT solution out there that's pretty common for mostly all IoT solutions, which is the things, insights, and actions. And that includes the devices, the cloud gateway, streaming the data, storing the data, and using the data to do something for you to actually take action on. And going back to this slide, if you're just building with our platform services or you're just learning how to build it in an IoT solution, check out the Azure IoT reference architecture guide, because that's a great way of learning what those different subsystems are, learning things that you need to think about when you're building an end-to-end solution, and be able to get started quickly. And I just want to jump real quick on giving an example of what IoT Central is. So as I mentioned before, we have all of these products and services on our platform side that helps you connect the device, that helps you process the device and visualize the device. But the thing with IoT Central is, let me actually create a box here. IoT Central actually acts like the manage app for all of these devices here. So IoT Central has the in the back end, we manage IoT Hub, we manage device provisioning service, we manage the visualization. So all you have to do is connect your device and then connect to Azure IoT Central. And then you can integrate it easily with your business integration and manage your application as well. And so this here is Azure IoT Central. Sorry, the live editing here. But all those devices or all of those products and services we just talked about of building your own IoT solution using our platform services is all managed with Azure IoT services or IoT Central's application. And normally I have a nice slide that shows that, but sorry if that had a live edit there, but it was really to showcase you have your Lego blocks, and then you have a fully managed where Microsoft manages all of those products for you, like IoT Hub device provisioning service, so you don't have to, and that you could just get running quickly. All right, so I'm going to go ahead and just walk through the demo for today because get us out of the PowerPoint world. But for this today, I wanted to just walk through a workplace health and safety architecture. You know how we manage, that I just mentioned all of those products and services and the subsystems of building an end-to-end solution. It maps really nicely with this safety architecture. So I actually have two parts of this demo that I'll do today. The first part is really the site safety. I'm going to be using an app, a cell phone app, that we're going to use as our device to track where workers are. So you'll see in just a moment, we're going to go through, we'll be using Azure Maps to help us create a geofence. We'll connect that to Event Grid with the Azure Maps Event Grid integration. And then we'll send an alert when the worker has entered an area that they're not supposed to be in. And so that's the first part of our solution, is site safety. The second part that we're going to go over is being able to check if your workers are wearing the appropriate gear. So this one, I built a model that shows, you know, am I wearing my medical mask or not? And if I'm not, we're going to go ahead and send an alert using Event Grid to alert one of our site supervisors that, hey, I'm not wearing my mask. And then we're also going to visualize that. So let's go ahead, let's jump into it. Let's do that first part of the demo. All right, so this is the Azure portal. I have all my resources already set up. If you are ever presenting or anything like that and you need to hide your information, we have this really cool handy tool called the Mass portal, and it's a Chrome extension. Really recommend it. I'm just going to do that call out, but it's a nice extension, and community member made that, so thumbs up. Huge thank you to them because that is a great extension. So for this, I have all my resources set up. I've created an actual app that we're going to be using right now. So let me go ahead. I already have it up. And this is actually supposed to be a web app that you can, or a mobile app. I'm using the web app at this moment. But you can see that we have all of these different workers. We're using Azure Maps to help us identify where all these workers are. And we're going to set a geofence using Azure Maps. And if you're not aware of Azure Maps, it's a set of APIs that helps you bring in spatial context in any of your web applications and your IoT solutions. So I'm going to go ahead. I'm going to set a geofence. First, I'm going to actually add myself to the map. Okay, perfect. So I've added myself to the map, and I'm going to set the geofence. And this one's the site safety part of the demo. I've set a geofence. This just means that, hey, you're not supposed to go in this area. I'm a newcomer. I might not know that, but let me go ahead, and I'm going to use this just to control where I am. But really, this should be on your phone. And so it will track your location using your cell phone. Don't have to use your cell phone. You can use an actual device. So if, let's say you have construction workers and they have a vest on or anything like that, you could put a little IoT device in there. Just for this one, we're going to use the cell phone as our things, so our device. So you can see now that I entered here, that it says, warning, Pamela's entered the construction zone without authorization. What's really happening here is that in the background, anytime that a worker is identified in this geofence that we've set up, is triggered an alert using Event Grid. And I don't want to get too product name heavy. I think I've done that already. But what's happening now that the trigger has been alerted, or the alert has been triggered, we should be able to go into our inbox and see that mail come in, which it did. And I can do that again, but so you can see that we sent an email to Megan, and that it said that myself, that I've just created, just joined into an area that I'm not supposed to. Actually says where I'm at too. And so this allows Megan to go ahead and contact the local supervisor who's on location to tell them, hey, you have an unauthorized employee here. We really need to make sure they're out because this could be a hazardous zone. So this is a part of the workplace safety that's really common across many different industries. Any questions on how I did that? Okay, perfect. And I just wanted to showcase, if you're ever working with Azure Maps, I love this site. So this is a GitHub page that links all of these different projects if you're using Azure Maps APIs. So for example, if you wanted to check the routing API, I'm going to go down here to demos. You can actually run the sample and you can view the source code and copy and paste it to your own application. So I'm going to open this in another tab. And I'm going to say from Seattle to Redmond, find me a route where I can actually take a truck that's carrying radioactive material. I wouldn't want to be that driver, but the reason why I'm showing this is to show that with routing, you can actually make it easy to do different like vehicle types and showcase different routing options. For example, if you're carrying a truck with radioactive equipment, you're not going to actually be able to take the same path as you would with a car that's not doing that. So you can see that the route with the truck is in green and the route in the car is actually in red. So this is just a great example of how quickly it was to get working with Azure Maps APIs, and then how useful this is for, let's say you're doing asset tracking or logistic management to use Azure Maps.
Pamela?
Yeah.
Was there a like a walkthrough for that geofencing demo that you gave? That was cool.
Yeah, there is. So I have this tutorial, the workplace health and safety demo. So this goes step by step on how you can deploy this particular demo to your own Azure subscription. And so let me go ahead, share that with everyone. If I can work Zoom. Been using Teams for so long. I'll insert the links after I'm done sharing. Sorry, folks, but if you go to GitHub, it's under Azure Samples IoT Demos. And under IoT's demos, you can go ahead and search for that. And so that will show, like, I'll show you the resources you'll get if you deploy that. So let me bring up the portal again. So it's pretty much an ARM template that you'll get. So it's a one-click deployment. I'm a big fan of the ARM templates. And so you will be able to get all of the different resources to do this. So you can see that it created an IoT hub for us, created a grid, event grid for us as well, an Azure Maps account, because you need an Azure Maps account to be able to use it and leverage the Azure Maps capability. And then, and I'll walk through this as well with the other one, but it has all of the resources that you would need. So if you built an app, for example, this Azure Maps app, you can go ahead and go to that site. And here's our app that we were just using. And so this is just a great way to start demoing and seeing how the products work together. So let me go to the second part of this solution, which is really the workplace safety. You can see that we have a camera. Bring this up real quick. We have a camera right here. It's the AI dev kit. If you haven't seen it before, I'm gonna hold it up to the camera. Hopefully you can see it. What this is just a camera that we partnered with Qualcomm that you can go ahead and deploy AI models to. So this actually has the IoT Edge runtime on it. The IoT Edge runtime is our offering to bring cloud workloads to the device. So if you wanted to run AI on the edge or do some processing on the edge, you can do that with IoT Edge runtime. And you can do that, you know, it just makes it easier to do it. There's other ways to do, you know, ML on the edge, like tiny ML. But if you're really wanting to be able to easily have containers and deploy them, IoT Edge is a great thing to look into. So we're gonna have that camera. It's connected to IoT Hub, so that's our cloud gateway. And what's gonna happen is when we do object, when the model detects when I'm wearing a mask or not, it's going to send that data up to IoT Hub, and we'll be able to see if I'm wearing my mask or not wearing my mask. So let's go ahead, and I'm gonna talk about how you can actually just make your own model. So this one, I was using custom vision. Let me see if I have it up right here. And if this is your first time hearing about custom vision, it's part of our cognitive services suite, but really this is just, it helps you make AI models that you can use on the cloud and the device side. So this is the portal. You can see I have a couple different models. I have one for workplace safety with wearing a hard hat, and then I have one for medical mask. So I'm gonna click on the one for medical mask. And the goal of showing you this is that it's really a lot easier to create AI models using cognitive services, using some of the open source community models as well, and building off of them. And so I just wanted to showcase this because I think a lot of people get really intimidated, especially if this is not their space, to create AI models. And so this one's using custom vision. And all we did was upload a bunch of images. So I got Teal here, but needed some more test points. And so you can see Teal is at every different angle. And we even have views on no one in the room. And then I have a couple images I've uploaded with myself wearing a mask and then myself not wearing a mask. And the goal here is that we need models to train this model, or images to train this model. So I have a couple untagged models, or images, and you can see that in order to train, I'm going to need to take my added tags and say what's happening in this photo. So right now, I'm not wearing my medical mask, and I really need to put that I'm not wearing it. So person with no personal protection equipment. I'm just going to save it. And then I'm wearing my mask here. I'm just going to simply tag, I'm a person wearing my medical mask. Saving it, and you can see everything's tagged now. I'm good to go. And I can go ahead and train. And it's as simple as that to do object detection with our custom vision. And you're going to want to make sure you have a lot of different images, because lighting, angles, all of that stuff is really important when you're creating an AI model. But at least you have this kind of nice, easier way to view and have a portal where you can easily tag images and use the power of custom vision and all of that research that went into it to be able to use that technology to easily train. After you train, you can go ahead and download this model or add it to Azure Container Registry. And I wanted to bring up, I've inserted this slide real quick to kind of talk about when you're building intelligent edge solutions and using that Azure IoT Edge runtime, what's actually happening. And so in the cloud side, we're going to have cognitive services. So we just built our model, which was that object detection with a medical mask. PowerPoint's going crazy. We built that model, but what do we do with that model? We could download the model and just install it on our device, which, I mean, that's definitely a solution, but we recommend really putting that model into some sort of container registry that's in the cloud. And the reason for this is because, let's say I have like 20 of these devices and I want to use the same model. You can imagine it's going to take a lot of work to sit there and configure each one of these devices by themselves, because you're just adding the model individually with these cameras. This, you have your containers already in that registry. If, let's say, you do an update in the model, retrain the model, you have a nice version control in the container registry. And then what happens is that you pick your container, and with the IoT Edge runtime, you can deploy that model on the IoT Edge device. And so I just wanted to highlight that real quick. So hopefully everyone understands what's happening, that I've created that model. I've put it in that container registry. That way I could deploy the same model to all different devices that's running IoT Edge runtime. Okay, so I have that model. I was worried about my internet. So I'm just going to go ahead and show a video of a live stream that I did earlier, but I'll show that it's actually, I have my camera on right now, but I'm just going to show this video so you can see it in action. So I have that Qualcomm camera, AI dev kit. You can see when I'm not wearing my mask, it says person not wearing their PPE. And then when I am wearing the mask, oh, I made a mistake of actually touching my screen. Sorry, everyone. Let me go ahead. I'm not sure what it looks like for you guys, but I'm gonna try to resize. Let's see. Okay. Go back just a little bit. So when I put my mask on, you can see it changes. And you notice that when I was putting on my mask and I had my hand over my mask, it actually said I wasn't wearing one. And that's because when you're training models, it's important to have a lot of images. And I could have had an image of my hand on the mask and tagged it saying, you know, hand on the mask or inappropriate, like not appropriate to have your hand on the mask, or there's something else I could have tagged and be able to identify, but we kept the model really simple here. So I have that camera, and now that it's already been deployed, I just kind of want to show in VS Code how I did that. If you're in Visual Studio Code, or if you're in Visual Studio or VS Code, there's actually a lot of really amazing extensions for working with Azure IoT. And so if I wanted to, I can go ahead and install those extensions, but I can install them individually, but I actually recommend installing the extension pack if you're working with our products and services, and that's Azure IoT Tools. And so you get a bunch of different extensions, which includes Azure IoT Hub extension, IoT Edge extension, and the Workbench extension. And I can tell my internet's going super slow because it's supposed to pile up. Come on, update. There it is. So you can see it's an extension pack that has all of your extensions that you'll need. And then for this particular one demo, I installed the Azure Machine Learning extension as well. And that's super helpful. It has example code to get started using Azure Machine Learning. I also installed an extension that had getting started code with that AI dev kit. So let me go back in the code and show you what's happening. So this is the deployment manifest. So this is just showing all of those system modules and the modules deployed on the IoT Edge device. So you can see we do have our getting started module that we deployed on our Edge device. You can see the module that we're running. And to kind of go back to my image, this was that model that we have that we're deploying on the Edge device. All right, and then to set up everything you need to set up, let me go back to environment. And this is going to ask for your container registry. Again, what's great of having containers, a container registry, it could be Docker Hub, it could be Azure Container Registry, it could be any really your container registry you prefer. But it's great that you can pick, you know, the models you want to use. You can do version control of those, and it's just simple to be able to take it from the cloud and deploy it on how many devices you want to deploy. And I'll go into the portal real quick. Back to my resources. This was my Azure Maps. Go back to my workplace safety resource group and that container registry. When I head over there, and this is all on the cloud side, you can see which modules I have. So that Vision AI getting started module and the camera tagging module and the web stream module is all hosted here. Okay, so one last thing I want to point out with VS Code is that extension. I mentioned Azure IoT Hub extension. What's nice here is that you can easily sign in to your Azure account, and then with this extension, you can send messages to IoT Hub. You can select your IoT Hub. You can get your connection string. You can create a brand new hub. Remember, the hub is your cloud gateway. You can create a new IoT edge device. You can monitor the data that's coming in and out. You can stop monitoring it. So it just makes life easier when you're using these extensions. I'm a big fan of them. So I'm always calling them out. And you can see in this solution, I actually have multiple cameras running at this time. And here's the camera that I have on my desk at this moment that I have live streaming. One thing I want to show, let me minimize VS Code. And I want to show how to visualize this data. So I have a time series insights set up and a nice environment. And time series insights is just a great way of just visualizing your data from IoT Hub. And it's really simple to create a time series insights. Actually, when you're in the Azure portal, let's see, go to the portal real quick. Just want to show, I'll go home real quick. Just going to show how easy it is to create a time series insights. I'm just going to toggle out of this real quick so you can see what I'm doing. There's actually multiple ways. You can click on here to get the resource. You can actually go create a resource. So if I wanted to do that, I can actually type in time series insights, or we have a section called Internet of Things, and you can get all of like IoT Hub, IoT Center application, device provisioning, and then you can also get other, these are the features, but if you see all, you'll be able to see everything that relates to our IoT services. You can even, in this search, type in time series insights and create a new environment. So with this, I'm going to go ahead. You can add to your subscription time series insights. And what you'll do is fill in this information, but you're going to connect it to your IoT Hub as well. So for this time series insights environment, all I need to do is select my Azure subscription, your location where you want to, for the database or the data centers that you want to use. So this one I could use West Coast, and then select your storage as well. If you want to do warm, you don't have to. You can enable it if you want to. And what is your cold storage? So let me just bring up time series insights. And you can see that this is all set up for me to view data. I have my camera already set up. I'm going to go ahead and add my camera to view if I'm wearing my personal equipment or not. So my medical mask. And with time series insights, you can view the last hour all the way to years and decades. So you can set that time span. I'm going to go ahead and select the last bit of time, because this morning I was playing with my dev kit. And you can see I was testing it this morning to make sure everything was working for demo day. I was taking my mask off and I was putting it on so I could easily visualize it. And so you can even do swim lanes if you want. If I wanted to visualize the other cameras, I can just go ahead, click on it, and then you get a full view of whatever you want to visualize. And so with this, let me see, I got my camera running, and you can also do auto refresh too. So if we have new data coming in, we'll start to see that new data. But I did a couple of triggers. I've set a couple of alerts with Event Grid when I wasn't wearing my mask. And I just wanted to show what that looked like in the inbox. So I'm going back to my demo inbox, and this was from this morning. And it was telling me that I wasn't wearing my medical mask and that that I've resolved it. And so this one was an alert that said that I wasn't wearing my medical mask, what camera I was using, and what time it happened. And so this is just a great way of quickly be able to get an alert and be able to do something about it. And you can use time series insights as a way to really gather that long-term insights. So for example, if I go back to this morning, if I was a site supervisor or working in a hospital or anything like that, and I was looking at the work shifts of how many of these safety violations happen, I'd probably question why there's so many incidents here, but yet the other work shifts are doing great. And so most likely more training is needed, or they would probably find a solution to lessen the amount of incidents in this one area. And that's really nice for folks who would say just needs to view the data quickly and make those decisions, because sometimes it's just easier to see it visually than look at a bunch of, a database full of information and try to get insights from that. And so being able to visualize it makes those decisions easier to see and faster. So any questions on this demo and how it works?
Feel free to come off mute and ask questions. It's perfectly fine. That's a cool demo.
Okay, hi, it's Dave here.
Yeah.
I've got a question, Pamela, regarding the actual device that you used. You used the IoT, the Qualcomm camera.
Yes.
Okay, what
So,
like if what about versus something like the NVIDIA Jetson? Is this a solution that could easily integrate with other types of devices as well?
definitely. The NVIDIA Jetson line, like for example, the Nano device. And for folks who are on the call who might not be familiar with NVIDIA Jetson line, they have a full line of devices that makes it easier to deploy AI models to the edge. We have support there with IoT Edge runtime. So if you actually probably could have just gone here, you can actually deploy IoT Edge runtime on a Jetson Nano or any of their Jetson line, which is really nice. I actually have one of these here on my desk. And what we have that full integration with DeepStream, with NVIDIA. So if you wanted to take that model, this model, you can deploy this on the Jetson Nano device. All you need to do is install the IoT Edge runtime, go ahead, put that runtime on the device, and then deploy this model. So this code that you have, you wouldn't use this this getting started module, because this is specifically for this dev kit. So there's some extra code in there to make things work with that particular dev kit. However, the same deployment, this would look similar. So this is your IoT Edge runtime manifest. And so you have your system modules, which is your agent and your hub. And then you have your other modules that you can create your custom code for. We just have custom code for like a web stream, because right now this camera that I have right at this moment is actually doing a web stream, which you can do with the NVIDIA Nano device. And we have we have a really nice tutorial that goes over that. let me find that. So Paul DiCarlo, I think he's actually going to, as Pete mentioned, he's going to be talking about NVIDIA Jetson IoT Edge. So he has a tutorial on GitHub that runs through that experience as well. So this one, and I'll put all of these links into chat as well, but it's Intelligent Video Analytics with NVIDIA Jetson and Microsoft Azure. It's a long, long name, but it's a really great one to check out. And he goes through a similar experience, but his scenario, I'm trying not to do spoiler alert because I'm not sure if he's doing this demo in his talk, is he set up a camera connected to his NVIDIA device. He's using a Nano, and what it's doing is just doing detection to see, you know, when people are coming up or down, it's up the driveway, anything suspicious, and he's visualizing it. And so all of this is all running with that custom vision AI with cognitive services, exactly what we're just using, and the IoT Edge module, blob storage, which I have on this camera right now. The only difference between this demo and Paul's demo is the fact that he's deployed it on a Nano device. So that was a long answer to say we have example tutorials for you to follow, and we work very closely with NVIDIA for that integration for IoT Edge. But you can use this same model on this camera.
Great. Thank you very much. Excellent answer. Thank you.
Pamela, one more query. Like I was concerned about the security wise. So if an edge has been configured, the IoT edge has been configured to an IoT hub, so we are pretty much sure there is no manual configuration on the security perspective needed, and everything is set up. We don't have to bother about the edge is talking to a right hub, as well as the hub is also talking to a right edge. There is no deception. So it's all ensured, is it?
Yeah, so there's actually a couple different ways we handle that security. So let me go back to that resource. Let me go to my hub. And I'm gonna go to my, so this is my IoT hub that's set up.
Okay.
And you have IoT devices and then your edge device. So I'm gonna go here and you should see a set of cameras. When I click on this camera, we have this securely connected to your IoT hub, and also you can securely connect to your edge device too. So I can send some information on how we do that, and I'll put that into the chat. But we do look into security here and have connection strings, but you can also use device provisioning service too. And with device provisioning service, you can have X509 certs. And there's actually a wide range of security that you can have in your end-to-end IoT solution. But for this one, I just want to quickly show you that you do have a primary connection string, and you also are securely connected with Azure IoT Hub as well.
Yeah, it's all inbuilt, you know. So what you have done is it's all inbuilt. So nothing. It's not much is needed. Okay, thanks.
Yeah, and I'll go ahead and send you a white paper on it too. But we have, as I mentioned, kind of the security on the edge side, on the device side, and on the cloud side when it comes to connecting devices. We also have the Azure Security Center for IoT, where you could deploy an edge module or an edge agent on the device. And that's an extra layer of security. So that's, I'm gonna do a spoiler alert. This is going to be renamed shortly, but this is Azure Security Center for IoT, and then Edge Agent. And you can deploy this Edge Agent. And remember how I said there is these different modules that you can deploy on your Edge device. A module, you can actually deploy the security module for Edge device using the Azure Security Center for IoT. So this is an extra layer of security that you can do that gives you more information about, if files are changed on your device or things like that. So let me send everyone that link as well.
Okay, yeah, that's great.
Yeah.
Okay.
I've done it, Pamela.
Oh, yes. Okay. Yeah.
You've done it. Oh, yeah. You have done it. Yeah, I was going to say, if anyone, I think you and myself have gone through every inch of Azure IoT and all of the products. So know it intimately. So, yeah. But let me show those links for everyone. And it looks like, oh, thanks for folks sharing a bunch of links in chat, I've just noticed. But yeah, it was great talking to all of you. And I hope that you guys have, if you have any questions, that was a really, really quick demo of just showing workplace safety and our platform services. I really could spend days and months training on those. So it's the quickest way of showing that.
That was really cool. Thank you very much. Cheers.
Thanks, everyone.
Anybody have any questions? Obviously, again, feel free to come off mute and just shout.
One more associated question, Pamela. Is there any way, because a requirement would be like IoT Edge, can we test it without an IoT hub? I want to emulate the IoT hub sending messages, but I don't have the access. I don't want to implement the IoT hub like whatever the Azure functions or whatever. So is there a way, automated way, where I can just test the IoT Edge in isolation and by sending some messages, not through IoT hub, but something else? Something like unit testing, or I think some isolation testing or something like that.
If you making sure I'm hearing your processing your question. So if you have an edge device, is there any way for you to test everything's working on the edge device before setting anything up?
Exactly. Yeah. Without interacting to the IoT hub, I want to emulate the IoT hub messages. For example, IoT hub is sending some JSON messages. I doesn't have to come from IoT hub. I just want to test it on my development PC or even in the edge device without interacting with IoT. So it's kind of isolation testing or kind of unit testing, you can call. Yeah.
Well, you can test the models on your edge device.
Okay.
And then if you, I think that would be one way that you can do that. If you're wanting to see it in the portal, that's a different story. But I think hopefully that answers your questions. You can test the models on your edge device for that testing. And then you can also test you can also do simulated data too to your IoT hub. But I think your main question is you just don't want to send that data up yet to IoT hub.
Yeah. Okay. We can do that. Is it okay? Yeah, thanks. Yeah.
You can even change the code where you're not sending any data to IoT hub. Maybe you have it connected to IoT hub and it's registering that, hey, this device is offline and the data's there, but you don't, if you don't want to send any telemetry yet to the hub, you don't have to. You can keep all that telemetry on the device side and only send up what you want to when you want to. So that's another way of considering doing testing.
Okay. Yeah. The why I asked this bit peculiar question is so one of the requirement is the need to develop the IoT edge, but the IoT hub is not ready. Okay, so a hub is done by somebody else. Just IoT Edge somebody else doing, and so I need to see what how it receives the messages and processes without the hub being ready. Yeah, that's the only why I asked this question. Yeah, thanks.
Well, I think when you can, what you can do, which might be a lot easier for you, is just go ahead and create an IoT hub on the free SKU.
Okay.
And when you're ready, when you have a different hub, you just switch the hubs out, and that way your edge is connected to another IoT hub. And that is probably, you can switch your resources to different subscriptions and different. Yeah, you might actually just want to change your resources at that point, which you can do.
Yeah.
Okay, yeah, I'll answer that and chat. Let me think about that for a moment.
Yeah, thanks a lot, Pamela. Thanks
One thing that's worth noting with the IoT Edge is also that it's all, I mean, you're essentially building a microservices-based architecture, right? All the modules, all the, some would call them the payloads that you would deploy on your Edge gateway. They're all effectively microservices. So you can like de facto, I would hope they are isolated, and that you find the right granularity when you design your service. And then the communication between the services, there is a message bus, if you will, in IoT Edge itself that you can use for like implementing RPC and like communication between the various services. So you can easily mock the service that's in charge of communicating with IoT Hub, and or the other way around. You may want to mock and simulate the service that would typically run image recognition. Maybe to begin with, you just implement something that's like spitting out simulated signals and simulated data. So you can do it that way. And this being all Docker containers and so on, you might, in some cases, actually, for like pure unit testing, you won't even need the IoT Edge runtime at all. You can just, like, this is just good old Docker containers, and you can also like test them that way.
Okay, yeah, thanks a lot. Yeah, thanks a lot, Benjamin. Yeah, cheers. Bye.
Yeah, great question.
Thanks.
Any other questions? Oh.
You beat me to it.
Yes, just. I had to answer the door and rush a little present from my mother for my daughter up into the bedroom, and then rush back down again. So any other questions, or have you exhausted yourself?
Yeah, it was a lot to cover.
That's good. No, it was really good demos. Thank you so much.
Yeah, Dave, I've got a question for you, Pamela, regarding this solution. I might have missed this part. Is there an ARM template that sort of just spins this whole thing up for you?
Yes, there is an ARM template. Now that I'm not sharing my screen, I can just go ahead and share this link for the team. So when you go to that GitHub repo,
Okay.
there is a nice ARM template that you can deploy, and just share my screen for 2 seconds again. So here's a GitHub repo that I shared. It gives that a little overview. If you want to do this demo and with any of your customers, but right here we do have that deployment. There's a few things that you'll need to do after you deployed the ARM template, and those are all highlighted here. And this is not going to take you very long to set up.
Okay, great, excellent, thank you.
Yeah.
Cool. Yeah, thanks again for that. So now would be a convenient time if you need to go to the loo or go get yourself another drink, or quickly gobble your dinner down, or any of those things, then that'd be good, and we'll get going with Benjamin's talk in, I don't know, if we say 9 minutes time to be accurate, go at 10 past, and then we'll do Benjamin's talk and demos and questions, and then we'll just try and persuade them both to stay along for as long as they can. the good thing is, of course, that I think at least I know Pamela's at least an 8 hours behind, but the downside is that we're in the run up to Ignite, as we mentioned earlier, and so I can only imagine how busy both Benjamin and Pamela are at the moment. Sort of indicated by the number of notifications that Pamela had flashing in her Teams there that she's happily.
Yeah, I just stop talking to people for the next 48 hours. I'm just pretending that people don't exist until certain things get done. Yeah, I really appreciate giving us time to chat today, and I'm excited to hear any of your feedback and more questions in chat, and then also see Benjamin's demo.
And in the 8 minutes that you folks have left, if you're not at the loo, start thinking about questions and or stuff you would like to see demo-wise in the second half of the presentation, because I have literally 0 slide. I have a bunch of ideas in terms of demos, but yeah, can be pretty flexible.
One of the suggestions that Benjamin said he might show would be code spaces for IoT stuff. So I've not seen that done. And I think Benjamin had a video recently which I'd implore you to go and watch as well. But it'd be pretty cool to see that demo. So that's certainly one that I'd like to add to the list.
Yeah, sounds good. Well, I don't have slides, but I certainly had that in terms of a potential demo. So yeah, we can spend some time walking through what would be the typical experience to, I mean, yes, sharing some tips and tricks in terms of the tools that are available. I think we kind of promised at the beginning that we would be diving into what is the typical anatomy of an embedded application using Azure RTOS as an example, but this would actually be probably pretty similar with other solutions out there. But yeah, how would you go about building your device? How would you go about making sure that that device that you build is effectively going to be useful, and folks will be able to, like in an IoT context, will be able to use the data that's coming out of it, will be able to send commands and control it. So yeah, we can talk about that.
Sounds good. I was looking at one of my clients asked me actually, is there any decent docs on, and this is quite a specific question, on the aggregation features in TSI, where you can choose sum and count? I can't find anything decent on there that actually explains exactly what they're doing. And I mean, it sort of sounds obvious, but when I tried to demo it to them, they asked me a specific question like that, and I couldn't explain it in good enough English to make it make sense to them.
What was the question that they're asking?
What they wanted to do is they've got energy meters now. Normally they'd just have an incrementing total energy, and they'd send that.
Yes,
that's what they had originally. But what I suggested to them is that doesn't actually give you very much valuable information. What you're interested in is the difference between the readings each time, to see if different times a day are consuming more energy than others. But of course, we're going to be sending, if you're using a constant amount of energy, say you're using, 2 kilowatts an hour, and you're going to send 2 kilowatts an hour, 2 kilowatts an hour, 2 kilowatts an hour. They wanted a way of being able to add all that lot together within a time period and show it was 8 kilowatts between 8 and 10. And I tried to do it, and I just don't know if it gave me the right information or if it was just user error. I did it in IoT Central, actually. It was a bit simple to do it in there.
Yeah, IoT Central makes it a lot easier to do that. I was going to say, you could use IoT Central, but they just want to use time series insights to do that. That's what.
Yeah, well, it's available to them. It's quite powerful. You can download it as a CSV or, view the raw data and stuff like that. It's actually quite a powerful implementation that they put in there, and dead simple to use as well.
Yeah, I'm trying to think the best documentation that you can use, because what are, I think we're probably gonna have to set up some time after Ignite to deep dive, and you can show me how you have it set up, and then we can make some changes. But it sounds like the goal is they want to see in a certain time span when they a certain amount of information that's being sent? Is that what?
Yeah,
And then how do you do the
sort
count?
of, instead of showing sort of, well, they wanted to show that you'd use like 8 kilowatts in that hour. If every 20 minutes it was 2
Yeah.
kilowatts used, or that's the difference. It's quite difficult to explain even in my head. Yeah,
Right.
It might be that so I'm sharing a link or a page to the docs page for the TSI query language specifically, but I mean, depending on the scenario, if you have an actual stream of data, the Azure Stream Analytics query language might actually bring you more, arguably more clarity, but also more flexibility in terms of how you actually design your average floating windows and whatnot. Although TSI would allow you to do the same, what might be true though is that we might be lacking a few examples to help exactly the kind of scenario you just described. It's should be pretty straightforward. I'm pretty sure we have some examples in a TSI showcase, which I think is part of the TSI SDK. The TSI JavaScript SDK on GitHub, I believe there's a few examples of queries there. But yeah, long story short, if you're looking at a stream of data anyways, then maybe just go for Stream Analytics. You will be able to actually turn your insights, well, not only into like figuring out whether or not you've consumed your 8 kilowatts or you've reached a particular threshold, etc. But those insights, you can actually turn them into proper events that can like trigger some alerts, trigger some serverless functions and whatnot. So I don't know if that makes sense.
Yeah. It didn't help that I wasn't able to actually use energy as my demo. So we were going on just the stuff that we were already sending up to IoT Central, and temperature was one of those. But the idea should have still been the same. But I think as well, the amount of data I was sending wasn't exactly consistent either, and so it was quite difficult to figure out exactly what it was showing me when I tried the different aggregation functions, and then when I tried to look for the docs that would explain it, I couldn't find it. So
yeah, that's I know it's possible, and I'm also trying to find it in the docs too.
Yeah, I seem to remember this being a problem when we were making the exam as well, Pamela, trying to find that sort of information to be able to ask questions on that, because it's quite, choosing that aggregation is quite a standard thing that you're going to want to be able to do. So
and I was pretty sure that we've updated the docs to have that, but I am looking, and I'm having fun looking for it.
Peter, was this within IoT Central?
Well, I mean, it's the same, I think, anyway in TSI, because the IoT Central one is just an implementation, isn't it? But yeah, specifically IoT Central.
That's what I was thinking, is maybe perhaps some of the functionality that's available in TSI individually may not be available in the TSI front within IoT Central.
Yeah, it was.
Yep.
But you would think that something as fundamental as aggregates would be there.
You would. Yeah, I mean, the functionality's there, but there's just no description. And in fact, I noticed as well that you can export to CSV and in that TSI within IoT Central. And I had to make a pull request to the docs to add that because it wasn't even mentioned. I had to do that because I asked a question about it in the exam. Yeah. But
I've got a lot of TSI notes here I could start going through. I'm sure we could help each other if you need help.
Yeah, thank you.
And Dave, I knew I recognized you. I kept looking at you. I'm like, I know I've seen your face before, because I definitely follow you on Twitter. And so I've
oh, do you? Okay, not too many people follow me on Twitter.
I follow you.
Thank you.
I've seen you enough on Twitter, so now I'm getting us follow. But I've definitely recognized you in a lot of your tweets. So
yeah, I've been following the whole Microsoft space in IoT for a number of years, including Benjamin when he was with the before he came to Microsoft with the
Eclipse Foundation.
Eclipse, right?
When I was before I joined the dark side? Or what, is that the other way around?
Are you kidding? It's not the dark side, it's the bright side.
Yep.
No. Yeah, anyways, thank you for the years of content both of you have been putting out in the IoT space. It's amazing how much it's progressed in the last little while, and how wide the Azure IoT, the sense of services, has become and is likely going to continue becoming. It's amazing the solutions that are available in tying all of these devices into insight and action.
Yeah, yeah. Normally I land that a little bit better. I was missing a key slide. It threw me off to explain the two paths. But yeah, I've noticed every time we talk about this, we get new products and people are like, how do we keep up? Because there's just so many new things in this space. And then now
Right.
that we have plug and play and Azure Digital Twins and everything else, it's just, we have to keep creating a lot of content in this space, because
Yeah.
I think more and more industries and scenarios are coming forward and be like, oh my gosh, this would be super useful.
Right.
Yeah.
Well, I have to compliment Microsoft on just simplifying the implementation of the complexity of getting device connected, and through IoT Central and IoT Plug and Play. That is a game changer for a lot of organizations that are trying to integrate, and not only integrate, but also can take advantage of the telemetry that that's only available in little silos at the moment, and being able to integrate that into their business right through to action and insight that they otherwise wouldn't have had. So compliments to the whole Azure team, the IoT team, for putting such a amazing suite of products together.
Thanks, Dave. There's heads up on the plug and play. So we'll soon be GAing the plug and play support for Azure IoT Central, and you'll see some announcements at Ignite. I'm not saying it's going GA at Ignite, the support for IoT Central. So I'm not giving that strong of a hint, but that support is happening pretty shortly, because we have preview support for both the platform services, the one way of building IoT solutions, and we're still preview on the IoT Central with plug and play. But what you'll see is kind of a rollout of us having that GA support for plug and play for the platform services, and then the GA for IoT Center with plug and play. But soon, I really think that story is going to be stronger once we GA on IoT Central.
Yeah, and you just got to keep on publicizing the fact that those services are available, and demoing what companies can do, so that it makes that so much easier for them to take advantage of that technology and see solutions that they otherwise wouldn't have had.
Yeah, I agree. I think sometimes we're kind of just throwing out products and being like, this is what you could do with it, but not actually showing a full solution sometimes.
Like practical solutions, showing it how simple it is, like, almost like, where you can have a printer and you can plug in a printer now to a computer and it'll automatically, connect, versus having to load drivers. Well, we're sort of in that paradigm with Azure IoT and the devices coming online. It's very similar, where it will be to the point where it's just plug and play.
I'm excited when that happens.
Yeah, me too.
All right, should we get going with Benjamin before he decides that he can't be bothered and just carries on listening to the rest of us? Thank you very much again. Great questions as always. I echo what Dave was saying about the content and platform that Microsoft are doing, and obviously a special shout out to the IoT show and the deep dives that Pamela's heavily involved in there as well, and Benjamin. So that's great stuff too. So yeah, we'll switch across to Benjamin and let him do his thing. Thank you.
All right, thank you. Before I get started, I'm going to make two assumptions, but I want you all to essentially clarify so that we are on the same page. One, I'm going to make the assumption that you're not afraid of seeing and maybe actually want to see some code. And two, that you actually may not want to hear about only about Microsoft stuff. And so hopefully some of the, but tell me if that's the case, but some of the stuff that I will be showing is something that I believe will be useful just for IoT in general. So quick show of hands or virtual hands. We good with some code and diving into some embedded code? I will take no answer as a yes anyway. So, but yeah, so and Pete mentioned that there was this code spaces thingy that he felt was intriguing. So I'm gonna walk you through like briefly what it would mean should you want to actually build a device. Like the thing with IoT is that maybe a few years back it was safe to assume, it might still be the case, but that like, is there such a thing as a full stack IoT developer? Probably, if you're a very small startup, if you have a super crazy idea, and hopefully, please, it's not a connected dog collar or like this kind of crap, but you may actually want and have the skills and the passion to do everything all the way from embedded to web applications, mobile applications, like the full-blown solution. More likely, the approach is more going to be I'm actually like the person who is going to build the device. Yes, it might be a connected device, something that might eventually join an IoT ecosystem, but I'm going to focus 100% of what I know, which is embedded development. And then some other folks might be more on the let's build the solution, the user-facing mobile application. And in that case, what they care about is having a nice, clear API to interact with your device, and they don't want to mess with the embedded code, right? So looking first at the embedded side of things, I want to walk you essentially through the Azure RTOS getting started. And this will be a good excuse. Again, yes, this is a Microsoft stack, a Microsoft product, but nevertheless, it's a good opportunity and a good excuse to walk you through the typical experience for an embedded developer who wants to write their IoT thingy, their connected gadget, right? So this is the Azure RTOS getting started guide. I think this is a bit too big.
Probably
well, yeah,
the opposite, Benjamin.
No, sorry. No, I was confused, and it threw me off that I actually landed directly on the README and not on the homepage. So I was kind of lost. So if I'm on the homepage, I, as a typical developer, but maybe I'm not, but and you tell me in the chat or just unmute yourself. What I typically do is I have a quick, really brief look at the README, but usually I'm like, I look at maybe the number of stars on the project, and just in general, if this is an active project, the first thing I do really is to just clone the freaking repo, right? And start hacking stuff on my PC, which I might do, right? And I can go there, just copy the URL, clone the repo, except that this only takes me so far in terms of, okay, I'm going to have the code on my PC, but if this is embedded code, I will need more than just the code. I will need the tool chains for cross-compiling. I might need some specific drivers, etc., etc. So the thing is that there is this trend in the industry. It's not like new to generalize the idea of, hey, you know what, containers, this is a great thing for isolating and defining very clearly what are the dependencies of a something software-wise. So historically, this is more like for the runtime microservices, but this actually works also for describing what are the dependencies of an actual workspace, right? And we can, before I actually go further, I can show you, and maybe a spoiler here, but in this particular repo, there is a JSON file, and I will make things even bigger, a small JSON file that seems to indicate that there is a Docker image that is associated to the workspace, a bunch of Azure, a bunch of VS Code extensions, and actually we should find, yeah, this should sound familiar. This is something that Pamela actually covered earlier, right? For this particular repo, it would seem that there are some IoT extensions that are recommended to be used, and so on and so forth. And so thanks to that, we can actually leverage something that's called code spaces, and that leverages the notion of like containerizing the actual dev workspace. So what I can
Benjamin,
do actually, yeah.
Your screen's a bit blurry, and the resolution looks quite low, and it's making it quite hard to see it with.
Blurry. Okay, interesting. Let me see. I might have
like it's sort of scaling up a 360p.
Interesting.
I don't know if
I'm actually gonna share my desktop for real. That'll be better, I guess. So let me just do that. Share screen.
Possibly the output res in OBS, maybe.
Yeah, yeah. There's probably a bit of that. If only I find where I should be able to share my screen. There we go. Screen 1. Yeah, and then I guess I can. Yeah. And yeah, that'll work just the same, hopefully. All right, thanks for the heads up. So yeah, remote containers for a workspace. What does that mean? That means that either locally on my machine, and I could actually I could show that in VS Code, like if I have the repo in VS Code, if I did go the old route, which is let's clone the repo locally on my machine and try and start hacking some embedded code. Like I said before, this is usually just the beginning. Having the code is not quite enough. You need the tool chain. You need you will have some headaches one way or the other if you're on Windows, and if the developers of the particular repo that you want to start hacking are on Linux, you will have issues. There was this pop-up that showed up just before, and which for some reason now it disappeared. Let me see if I can have it back. Yeah, there it is. Would seem that this folder contains a dev container configuration file. Do you want to reopen this particular workspace, but with the actual workspace being a container? And yes, sure, I may want to do that. In which case, I will like run everything locally on my machine, except that the dev environment and whatever is going to be used to compile the code and so on will be, again, super well defined and living in a container. So that's great. That's great if I've cloned the code locally, which yes, I did. You haven't, right? And someone who stumbles upon the Azure Autos Getting Started or on any repository, really, the new experience, this is in beta right now on GitHub, but this will soon be publicly available. And if you sign up for the beta today, I think the waiting lines are pretty short. If you want to be fast-tracked, maybe I can help or can try at least. But if you have access to code spaces as GitHub code spaces, it means that what I've just shown in VS Code, you have the equivalent, but with the container itself being deployed somewhere in the cloud, which means that I can like spin off and spin up a new like full-blown dev environment with the everything that was described in the JSON file that we've seen earlier. It's going to be provisioned, right? And that's what's happening right now. So we're literally like setting up the entire environment from scratch. I think it takes a minute and a half, like literally just a minute and a half to get this fully provisioned. Not only does it clone the code, all its dependencies, like the Azure Autos repo, it actually has some Git submodules for getting the embedded SDK that you're going to use to connect to Azure IoT, for getting the actual Azure Autos ThreadX code, etc., etc. So all that is being cloned, and once that's done, next step is to augment the container with not only the code, because you only get so far with the code, but also all the tool chains and also all the extensions that might be needed for and that were part of the JSON file and that describe what extensions are expected to be in the workspace for a good developer experience and for the stuff to work in the first place. Such an extension actually seems to be, like I was mentioning, let me make sure that this is slightly bigger. One such extension is the Azure IoT Hub extension. I'm going to need that if I am to connect my device to Azure IoT. Let me see, just making sure that there's no questions. Okay, all right, so I have a full-blown dev environment right now. Full-blown as in like looks and feels very much like VS Code. I have an actual shell. I have an actual tool chain, which is somewhere, sorry, I think it's installed in work, is it? Yeah, I have like the GCC GNU ARM embedded tool chain, and please shout if this is too much code or too far away from what you're expecting from the demo. But I would hope this is actually the other way around, and you will have questions and will want to ask whether this or that is possible. So what I want to do, and maybe I will, since my setup is not like I wanted it to be, let me share. Let's see. I'll try to. I don't want to do something stupid. What will be the best way for me to share the? Yeah, I think this is at this point where I will maybe have some trouble using the setup that I was planning on using. So just showing on the camera what is the board that I want to target and for which I want to start writing some code. It turns out this is one of the boards that are supported out of the box for Azure Autos, and this is an STMicro board. So I can probably have a look at what's in the sub folder, the STMicro subfolder in the getting started. There is actually a workspace already. So let's switch to that. And let's start to write some code, right? So the beauty of having everything living in a container is that yes, Azure Autos and the getting started samples, just like many other embedded projects out there, they leverage CMake, except that, well, for CMake to work, you need a tool chain. Well, the tool chain is part of the container, so just need to just confirm that it's there, finish the configuration, and I can start hacking, right? And I have, again, this is a full-blown IDE with everything that I would expect in terms of, I want to have a look at the main, and like I want to have all the goodness in terms of code navigation, control click. Yes, it takes me to whatever Azure Autos header file for like for me to start to explore what this is all about, right? And actually, what is it all? What is it about? Well, in the main file, for a typical Azure Autos application, the typical anatomy for the Azure Autos application is that for this particular STM32 board, there is actually some hardware initializations that need to be made in terms of like configuring all the clocks and so on. And then this is a real-time operating system, as in rather than writing code that runs straight on the metal, you actually have a higher level of abstraction, namely things like threads, like shared memory, like semaphores and eventing for implementing synchronization and communication between your various processes. And so the typical entry point for Azure Auto ThreadX is this method here, which ends up among other things, looking at whatever you have in this method and in this entry point. And in my case, for this particular application, there is just one thread, which is called the Azure thread for debugging purposes. It has a name, it has a priority, just like if you were to use something like Java or .NET or anything really. You're running on a very small micro, and yet you have potentially multi-threading. And this particular thread, it actually has an entry point, which is defined here. And look at how I can really easily navigate the code as I have a full-blown ID. I have code completion as well, right? If I were to try and print F, I have full content assist there as well. If only I knew how to type. So the entry point is, we don't need to dive too deep into that. We can actually probably debug later on, but it sets up the Wi-Fi stack. For that, it actually leverages a companion to the Azure Autos ThreadX core building block, which is the NetX network stack, which helps with having like a portable TCP/IP and networking stack. And then it ends up at some point doing some MQTT stuff to connect to Azure IoT, and we will dive into that a bit later. One thing, the next step for me, and obviously this is the getting started, so there's a bunch of boilerplate code that's already in there, but this is essentially your starting point if you were to build your own device, right? Just like if you were to start with like ARM Embed or any other embedded platform, you would probably start from an existing Hello World kind of application, right? This particular Hello World already has all the plumbing and all the scaffolding to connect to Azure IoT, to do to get some data of the sensors, so you have a good starting point. And in fact, for this particular getting started sample to start working on my in my environment, I need to just provide the configuration here, right? So this is where I realized that with this particular setup, I won't be able to obfuscate as much as I would have hoped, but that should be fine. I leave. So that's my Wi-Fi credentials. Ooh. Yep, you didn't see it. You didn't see it. Next, I need to connect to Azure IoT. And so how would I go about doing that? You need an Azure subscription. And again, if you're not a Microsoft kind of person, like you want to connect to some kind of IoT backend. Here we're connecting to an MQTT broker at the end of the day. For connecting to this particular MQTT broker, there is an additional workflow that Pamela briefly described earlier, where we have this notion of a secret that is used to generate small temporary tokens for establishing the connection. And essentially, all I need is the name of quote unquote broker of the endpoint that I want to talk to, the IoT Hub endpoint, a device ID, and a key. So for getting this information, and since I actually already have an IoT Hub already set up, I can just try and use the Azure IoT Hub extension, which is already part of my workspace. The only thing that it doesn't have is it doesn't know yet how to talk to my particular Azure cloud subscription. So I can quickly, in literally just a second or two, connect and combine and pair this particular code spaces to Azure IoT, to Azure, and to my Azure subscription more specifically. I have an Azure IoT Hub in my subscription. That's great. What that means, and maybe I should make things even bigger. What that means is that right from here, I could use the command line, I could use the web UI, but I mean, this is an IDE. I might as well use the IDE. I can right click, no right click. I can click here in the three dots, create a new device, which I'm going to call STM Nuts. Device is created. Now I think I have all I need. The host name is right here. The device ID, I think this is STM Nuts, and the primary key. So now next step will be I need to compile the thing, right? And on the old way on my machine would have been headaches after headaches of I didn't get the right version of the GNU ARM embedded toolchain. Oh, by the way, I don't have this and that. Here, I just go cmake build, and it should take, I don't know, 15 seconds. All the compute resources, again, are in the cloud, right? This is part of like the GitHub Codespaces service. I don't know off the top of my head, but I think it's some kind of like 2-core Linux-based machine. So it's actually quite good for most use cases. And I don't know what the sort of like the final pricing and offering will be, but I'm pretty sure there will be, if you need a beefier workspace and a machine potentially with, I don't know, a GPU on it, this might actually be part of the offering. What do I have? I have like a build that's completed. I have a binary. Now I want to actually like run this on my device, right? I could go about like trying to look for, like in the build folder, there actually probably is, yeah, there is a binary which I could actually download and drag and drop. You might be familiar with those embedded devices that end up showing up on your PC as a mass storage device, right? So where is it actually? I can see it. Yeah. If I just plug it, it should show up. Well, no, sorry, it's not a frequent folder, I guess. It's here. I could actually download the binary and like sort of drag and drop the thing. And for this particular device, this would work, except that I probably wouldn't be able to debug. It would work or it would not. So what I'm going to do is run OpenOCD locally on my machine, so that from the cloud, from this environment that runs in somewhere in the GitHub data center, I can actually start pushing bits and pushing and do GDB essentially and do remote debugging. All right, so I'm doing that. I need to do just one more thing, which is, yes, I've just opened OpenOCD on my machine, except that it's right now listening on localhost. So I need to make sure that this can be reached from the cloud. So I will use, there's many ways I could do that, but I'm going to use ngrok, which just ends up setting up a TCP tunnel, which means that right now, and this is completely not secure at the moment, we are going to improve the experience over time. I'm just showing you what's possible, and it's going to be our job in the next few weeks and months to make that like even more mainstream. But it's still like it's something that's besides the GitHub Codespaces thingy, which is still in beta. Everything else, like it's available today, right? And you can take some inspiration maybe from this demo to start tweaking stuff according to your needs. But yeah, this particular endpoint is all I need to start doing to actually start like launching and debugging. I actually don't know I know the shortcut, which is F5. I don't even know what it would be in the palette. I wanted to show you rather than hitting at F5. But yeah, let's just hit F5. Hitting F5 means that I'm launching the project, and typically the project would attempt to connect to a local debug port. This time around, it's a remote debug port. But yeah, this should work. We see OpenOCD doing its thing. It's actually deploying the code, copying it in RAM, running it, and we actually hit a breakpoint. And this is I've started from nothing again, right? From literally an empty a GitHub repo, which I just stumbled upon, and now I have I don't know how many minutes into the demo, but I can start debugging, right? I have access to can dive into the code itself. It might be a bit slow, but not that slow actually. I can start debugging the variables, except that I don't know if there's some this is my debugging stuff. Enough with the debugging. I'm assuming that whatever I put in the config file is enough for my device to be connected. Let's see, is my device connected? Well, yeah, well, it's there. Well, no, sorry, it's there because I created it, but it was blue just before. I refreshed, now it's green. It's actually connected. What that means is that I can start playing with it, playing as in the device might actually be plug and play in the first place. So what that means is historically, and this is true, again, this is not like Microsoft specific or Azure IoT specific. Historically, you might or might not be aware that however great MQTT is, it doesn't standardize at all how the payload should look like. So having a device connected to an MQTT broker is one great first step. You will be able to get some bytes off of it and hopefully to send some bytes by sending MQTT messages. But it only takes you so far if you don't really know what the payload actually looks like, right? And so typically, if my device was not a plug and play device, I would have to look at the specification of the device, maybe reverse engineer the code, being like, okay, yeah, the device, I can send commands to the device, send MQTT messages, if you will, but what is it really that I can send? Like, if I send that, is the device going to understand it? You don't really know, and this is sort of where we've been for the past decade or so, if not more, with M2M before IoT, in terms of having this impedance mismatch of devices, yes, that are connected, but that's only the first step. So my device is connected and still is, apparently. It's all green, but it's also a plug and play device. What does that mean? If I were to look slightly more closely at the code for the MQTT thread, one of the things it does, one of the first thing it does is that it establishes a communication to the MQTT broker, Azure IoT, but again, that doesn't really matter at the end of the day. But it uses a convention, which is, hey, I'm going to connect to and this particular convention, this particular approach is something that that can be replicated and ported across other stacks, right? And this plug and play thingy that we came up with at the end of the day is something that's really not looking you to Microsoft, quite the opposite, actually. This approach, this convention is, hey, at the time you connect, how about you make it part of your payload, your like initial sort of birth certificate, to tell the broker, here's my model, here's the URN, the short version of my quote unquote model. And this particular model is something that I've actually been authoring, or the person who's built the Getting Started authored before me. And this particular model is simply a JSON file, very standard JSON file that describes the capabilities of the device, right? And there is actually, just for the anecdote, there is some tooling support in VS Code for this particular file as well, as in if you were to add a new type of property, of supported property. I mean, you would be able to, well, not only give it a name and so on, but have some nice content assist for giving it a measurement unit, etc., etc. Right? This particular unit is of type time span, so automatically you're sort of constrained in terms of how you're going to, like, more specifically, what is the unit for this particular telemetry. And same, there might be some properties that the device understands. There might be some commands. And so that's the whole idea behind this notion of a model. And really, from like a pure code perspective, it doesn't mean much more than when the device connects, it sends, as part of its birth certificate, it tells the server what is the model is going to be following, like what specification it implements, essentially. And then whenever the device effectively talks to the cloud, it makes sure to send data according to what it's agreed to follow in terms of specification, right? So long story short, what this means is, as a data consumer, I know exactly what I can expect as an app developer, really. And so I don't think we have the best tools just yet to show that straight from VS Code. So I'm going to revert to using a tool that actually runs on my desktop. Kind of defeats the purpose of having code spaces like cloud-based demo, but you will get the idea still. So the and for that one, I'm not sure I will be able to make things bigger, maybe from the developer tools. No, yeah, the key binding might be disabled. Sorry about that. I'm sure there is a magic shortcut, but this will have to do. Hopefully it's not too small. But with this particular tool, I can also interact with my device. And this one tool, which is, and this, for those who are familiar with IoT Central, like this is similar to the kind of interactions you may be able to have from IoT Central as well. It's just like knowing that the device is plug and play, essentially from the tool, even before like starting to hand things over, I, as an embedded developer, to hand things over to my front-end developer who maybe will want to write like a Node.js application or something. Maybe I want to like quickly check that everything is working and that the device is behaving as it should. But since it's plug and play, well, there's not much to check actually. Since it's plug and play, automatically we know what are the properties that the device supports. I can like send and tell the device, hey, starting from now on, the telemetry you send not every 10 seconds, you send it every second. Dear device, it would seem that your there are some commands that you are you can handle. So there is just one LED right now, and hopefully you see the webcam. I understand it's probably really small, depending on how Zoom are laying things out. But if I click here, I just sent a command to toggle the LED. Yes, this is the IoT sort of hello world still at the end of the day, but this is a hello world that just works, right? And that's what plug and play brought to the mix. Telemetry, same. Like, I mean, I want to subscribe to sort of the fire hose and the feed of data coming off of the broker. If I were to not use plug and play, I would like start receiving payloads which I may or may not be able to understand and which I may or may not trust. With plug and play, like I can actually switch to this view where the tool actually knows that, hey, you know, the data, I know for a fact that it is in degrees Celsius. Like you've told me that in the model, right? So I know that, and I can show you the data, right? And so we have a device that's connected, like I've started literally from scratch, from a completely empty environment. Obviously, this is like a device that's powered by ThreadX. So there is a rich ecosystem of libraries, which I believe Pamela covered earlier. It's not only about like ThreadX as the real-time OS. It's not only about NetX as the networking stack. You can also do GUI stuff, right? If you want to build in just a few kilobytes of flash and RAM, you want to build like interactive menus on your tiny LCD. Maybe you want to have some like animations, menus, and whatnot. It might be great to have a library for doing that, a portable library. That's what Vuex would allow you to do. But yeah, so that's on the embedded side of the demo. And thanks, Peter, for dropping all the links in the chat. One last thing that I want to show, sort of along the lines of what I was saying, a typical IoT solution would be like, it's not about being a full stack developer that's going to take care of doing everything from like the same environment and dealing with embedded and Node and Android development. There are several parties involved, and so another party that might be involved in making my device actually useful and turning it into more like a solution would be maybe a front-end developer that wants to use JavaScript and whatever APIs they need to use for building a web UI that gets data from the Azure IoT backend and displays it, etc. And I want to like briefly show what the experience would be like switching hats and sort of being a completely different developer now, who's going to use code spaces as well. That's the interesting aspect of code spaces, that it works for all sorts of development. So I'm going to take a repo that I have. I think it's private right now, but if folks find it useful, I can turn it, make it a public repo at some point. But this is essentially the repo that the web guy, the web person, would be using for the web front end for the application. So just like earlier, I'm going to clone and start the associated code spaces. I think this one might be slightly faster to provision, but let's see. In the meanwhile, I will maybe make sure that there's no questions that are lined up, and or if you guys want to go off mute anytime, of course. And this is just like literally two more minutes for this particular demo. We're going to provision the environment, and this is going to be Node. And I guess just like, maybe to a slightly lesser extent, but just like the nightmare that I described earlier for a typical embedded developer, we would need to download CMake, a tool chain, maybe make sure that the Linux code works well on Windows, and like set up Windows subsystem for Linux and whatnot. Kind of the same for Node, frankly. Like, do I have the proper version of Node? Am I really going to get and download all the npm packages properly? And do I really want to clutter my local machine with a gigabyte worth of dependencies and IDs and whatnot? I might as well, especially if I'm a web developer, I might as well do everything right from the web. And yeah, well, this, but no, I don't want to allow the linter to, I don't want to turn it on, but let's see. So that's the code space this time around for my web app. So what the web app does, and I'm assuming that you might not be necessarily JavaScript developers, so I don't need to dive too deep in the code, but there's just one thing that I want to call out is this app, and you will see in a minute what it does. It doesn't do much, but the cool thing is that what it does and the way it interacts with the device through the IoT Hub APIs is effectively by also leveraging plug and play, and by leveraging the fact that we have this model that we all know, like us as embedded developers from Contoso or whatever is this company was working on this new connected gadget, and us web developers, we've all agreed that we're going to use the same model. And so we know for a fact that there is a particular command that that can be sent to the device. And I think I will need to make sure that I actually call it that way. And yeah, there is this particular command that we send and that will be supported, and we use for that like the Azure Digital Twin APIs. What else do I need? I will need to set up some environment variables, I think, before I like typically what the web developer would do is once they're happy with their app, they want to start and test it, right? And yeah, if I want to start and test it, I will need to set up and to put my IoT app connection string in there. So let's just copy this from, I could copy it from the portal or from like, wherever I have access to that information, but I need to call it IoT hub connection string. And I think hopefully you can also start thinking, and again, I'm sort of flying blind here, but I'm assuming that some of you are like actual developers. And I think it goes without saying that this kind of stuff goes further than like simplifying or changing the way you actually develop. This also changes the way you do DevOps eventually, and like the way you do your continuous integration, because your code base, you've essentially started to describe like super precisely what are the different things that are needed to make it run, to test it, to run it. And so whatever I'm doing here, like setting up this particular env variable in a CI/CD environment, maybe this would be pointing to your test environment, to your pre-prod broker, right? Here, I'm going to point to my local, to Benjamin's, the web developer testing environment, right? So pasting my connection string. Oops. Whoopsie. You get there eventually. And pasting, yeah, I don't know how the other variable is called. Yeah, the other is the name of like the sort of the fire hose I'm going to get data off of. And this one is called default. And I think this is how I should spell it. Now I should be able to start the app. Now the app is running. It's a web app. It's a web app running in a container somewhere in my GitHub code spaces. How do I test it? Well, luckily, something that GitHub code spaces does is that automatically it exposes. I think I didn't. Did I launch the right workspace? I might be running off the wrong branch of my. Let's see. I just need to check quickly. Yeah, no, I should be good. I'm just confused. I think they changed some things in code spaces since yesterday. Let's see. Starting the app, and so apparently it's not forwarding my my local port automatically. So I'm going to actually do it. I'm assuming that the host. Ooh, interesting. I'm going to do it manually. Then I want to forward port 3000. Interesting. The good and the funny thing about running off of a beta version. I'm really confused at the way it looks.
The beauty of live demos. And
yeah, well,
doing
it
that
looks like
on
it's actually almost like doing something, but not to the point where it actually works. The host may not. Yeah, there's some IPv6 stuff going on too. It would appear. Why would it not let me? I guess what I could do is switch back. Yeah, you know what? It might fail as well. But one thing that I want to do is show you that this code spaces thingy can also run, and I can leverage it like locally on my machine, right? So I should have, I think, the same repo cloned on my machine. It's called, yeah, that's the one. So I'm going to open it. I'm going to make sure that I'm running off of the proper latest. already up to date, is it? I'm just not fully sure that I'm in sync. Let's see. Are there questions in the meantime?
None in the chat, but obviously, again, feel free to come off mute if you've got anything to ask. I mean, I'd like to see like an end-to-end Twitch stream of this, taking you from sort of zero to something working. That'd be awesome.
If you host, I'm happy to join you.
Brilliant. I need to go and buy one of those boards. What board is it again?
An STM32 L475. I think Pamela can probably paste the link. It's a BLE plus Wi-Fi Cortex M4 low power kit with a bunch of sensors like a gyro and accelerometer and stuff like that. Okay.
Looks like Mauser do it, I think. Oh yeah, this is the.
Yeah, it's like one of their very popular kits.
I'll add that DigiKey link to the board.
All right, so I just cloned the repo. Now it's telling me, hey, you might as well open it in a container. All right, I'm going to open it in a container. We can show the logs. So this is using Docker on my machine this time around to provision like a similar environment to what we've seen earlier. It's downloaded the image. Now it's downloading all the dependencies of the web app so that I don't have to bother about doing that. Like the first time I'm actually going to open the repository in my code spaces, it's already going to be like ready to go, ready to do the start thing that I did earlier, and it should work. So it's cloning the world essentially, and downloading the world in terms of dependencies. That's sadly the way some Node.js applications do. I think there's probably 500 modules that this app is getting, but it seems to be getting there. And the Azure Autos getting started repo also has samples for a bunch of boards, including the MX chip that I'm pretty sure you have handy, Pete, and maybe others. And it supports the same workflow. So you could try that too. There you go. All right. Hopefully this will eventually finish and resolve. Maybe not. I guess another option would be I do the non-containerized version of the demo that too would work, so that I can show you the what the very simple web app does. Yeah, let's give this a couple more minutes or seconds. Yeah, in the meanwhile, I'm gonna just clone the repo once more, and we're gonna just run straight off the repo with no containers. Right. I think it's just that there's just so many dependencies that it's taking a while. Yeah, 358. All right. Yeah, I think I'm gonna give up on this guy. I'm just gonna run with no container, I guess. All right. Just a quick look at this thingy that, yeah, we might need to change. I think I have hard-coded this. And then setting up the env variables. Where are they? Yeah, I knew I had them handy. Connection string. This one I don't have. IoT hub connection string. All right, start. Okay, the app is running. One thing that I need to do, I should make sure this guy is not running. And now if I go here, this is what the web app does. It doesn't do much, but, and I will need to change the zoom level just slightly. Where is my command? I think there's something that I forgot to. Where is my command? Well, I guess I didn't commit the latest version of my code. There should be the command to toggle the LED. Not sure why it's not there. But yeah, I mean that's the app. It doesn't do much. I only wanted to show it just for the sake of showing that code space is something that you can use no matter what kind of developer you are. And thanks to plug and play, you actually know what data you're going to manipulate, both in terms of telemetry and sensor data and so on, that you're feeding into your web UI, mobile UI and whatnot, but also in terms of commands that you're going to send. And you know for a fact that the command takes this and that parameter and sends this kind of reply, right? So I think that's what I had. Questions?
That's really good. I recognise that that web app there. That's a sort of a hello world for looking at and graphing IoT data, isn't it? Your webcam's frozen, by the way, Benjamin.
Okay, interesting. I think if I turn it on and off, it might come back. It might not.
That old chestnut.
Yep, there you go.
Oh, there you are. I see you. Has anybody got any questions? And again, feel free to come off mute.
I'm going to raise my hand and ask a question here. Benjamin, regarding like code spaces, I've used Platform IO as an extension to sort of reconcile all of the dependencies when it comes to the different libraries for devices. How would you be able to take advantage of both of those, or even whether or not is there any conflict between using both code spaces as well as Platform IO?
I can't think of any conflicts. And as a matter of fact, I could actually like install Platform IO within my code spaces. Okay. I think
that likely answers my question. I just wanted to make sure that there's no conflict in terms of being able to use both of them within code space.
Yeah, I think you could use both, and just like the experience you would have locally on your like today in VS Code, however feature complete Platform IO is, it only takes you as far in terms of, I mean, it's very focused on like pure embedded code. It's not like it's going to, it doesn't have anything Azure IoT specific. It doesn't have like, if you want all your developers in your company to use Platform IO, that's one thing, but you might also want them all to use a particular set of extensions, maybe some extensions, VS Code extensions that you've developed in-house for like authoring some config files you may have, etc. Right. So with code spaces, you can like describe what all those dependencies are, so that like all the developers that you onboard, yes, they start with Platform IO, but they also start with all the repos, all your company's repos that are cloned exactly the way you would like them to.
In terms of, the CI/CD process.
Yep.
Excellent. Okay. One more question. Do you know if would I be able to run that demo with the Nucleo, the ST Nucleo series of boards? It should be able to, right? It's also based on the same processor. It's an STM32, but it's not the L.
Yeah, if I mean the getting started, it's the one that you'll find on the Azure Autos getting started. It's for like this particular board, so it has it might have a couple files here and there with like the a few lines of assembly for bootstrapping specifically. Like the clocks, etc., for this particular board, but you should be able to just copy paste and like replace the files with the. I mean, out of the STM32 typical sample projects, you would have those bootstrap files and so on. So you should be able to replace.
Okay. I'm gonna try.
have it
Thank
run.
you. I'm sure. Yeah, I'm pretty sure it will. Thank you.
And there's actually some like strictly speaking, it's not in the Azure Autos getting started repo. It's more in the Azure Autos samples. Go figure. But you have some samples for another flavor of STM32 kits, which one that has an LCD display, and so this is actually a good way to have a demo of UX and how you would implement an odometer kind of UI, maybe this kind of stuff. So I'm gonna the link in the chat.
So many toys.
Mm-hmm.
You need all the toys. Pamela, you're on mute, don't forget.
I was just agreeing with you. Yep. And I sent a lot more DigiKey links for the team. I'm sorry.
This is one of the minor benefits of running my own company, mind you, is that I get to put it through the company and then just blame the company. My company wanted me to buy it.
I am fully leveraging that Microsoft money
So
on
you
budget.
should. Yeah.
I need this hardware for demos.
I'll keep actually, from my perspective, keep pushing Microsoft to create some demos around like the MX chip, because I know that they've been giving them away at times, and it's a great opportunity to to start in the IoT development space.
Benjamin's got a really good workshop, like an end-to-end thing that takes you through sort of asset tracking with the MX chip device. That's really good.
I'm aware of it. It was a great. Like I can't imagine the amount of time and effort that went into that. You did it for one of the conferences about a year ago. I don't recall which one. It was MS Build, perhaps.
Yeah. The first time was actually Ignite,
Ignite.
last fall. Yeah, last fall. It was in November, I think. And then virtually for Build. Yes, it's a fun workshop.
It is. It's a great workshop, Benjamin.
And the stuff that I'm sharing on my screen right now, this is for you, Dave, but for others as well. Like this is the STM32 sample that I was mentioning earlier. So it's not the one kit that I was using in the demo earlier. It's not the Nucleo either, but this is another discovery kit that has an LCD, and among the various samples, there are the samples for UX stuff. And actually, what I really like about those is that this is like really super like lightweight kind of app. The code when it comes to using UX, it's really just a few lines of code. And actually, just for the anecdote, the way it works is that, and I think it's brilliant actually, but there's it's not new. There's other vendors who do the same, but you have maybe I can share it real quick. There is an actual tool, a desktop tool that you can use for Let me try and share it. Yeah, there we go. You essentially, ahead of time, before writing any single line of C code, you author what your UI is going to be in terms of what are all the sprites that I want to use for my animations, what are potential interactions that I have in mind. I want to, whenever event X happens, I want to switch to a particular subscreen, or I want to toggle the visibility of a particular sprite on the screen. And so all that you author through this desktop tool.
Wow.
And at the end of the day, it spits out the actual, like the C code. It generates the C code with all the like all the bitmaps,
Right.
the C code with all the event listeners, and it taps into the Azure, like the bigger Azure RTOS picture where events and shared memory and so on are a first-class citizen. So when a thread wants to signal the UI that there is like something that happened, well,
Okay.
that just works, right? So you model what are those events that you want to react to, and then maybe I can switch. And I'm actually not sharing my whole desktop.
Is that a third party?
Sorry, what's that?
Is that a third party application?
Nope, the tool you can get, like if you go to the UX doc and so on, like it's free, it's out there, and it's part of the package, I guess, right? And so if I go and find the equivalent of the UX demo, I'm actually switch to VS Code maybe at this point. Let's see. Opening this in VS Code, and I'll be right back with my desktop. All right. Sorry, hopefully you guys are not epileptic or something. There goes. So most of the code for this particular app is code that's been generated by, this file is the one file that I was authoring earlier, describing what is my GUI, what are the potential interactions and so on. And then it ends up generating the code. I mean, if you've played with Arduino LCD displays and whatnot, like that sounds familiar, right? Those are the bitmaps for the actual sprites, maybe the bitmaps for all the fonts that I use. There's probably also some headers for like configuring the app. There's probably also some headers in terms of the various callbacks for the event handlers and so on. And I mean, this is all the boilerplate code that's automatically generated. The main, like the core of my app at the end of the day, it's almost nothing, like TX application define. Oh yeah, sure, I have a UX thread, and I mean, this is most of it has been generated, right? So long story short, I don't know if you will have a sample that works just out of the box for your particular Nucleo board, but even if you don't, like, it shouldn't be too far from being able to start playing with things. And I know there's also, in the latest link that I posted, there's also a bunch of samples for MX Chip. Pamela might know. I don't know if there's a UX sample in that one, because MX Chip has an LCD. So I'm having a quick look. That might be an option. If no, there's literally just one sample in there and doesn't seem to have UX. Well, you know what? This is all on GitHub. So if you end up writing a UX driver for the MX Chip screen and so on, you might beat us to it, right? Just open a GitHub issue. Tell us that you will be hacking a few things. That might be fun.
Cool. All right, great. Thank you. Wow.
And then I added the link to Azure RTOS samples, and the direct one for if you have the MX chip. We just released a getting started guide with MX chip plus Azure RTOS, because it's really based off the ST MCU, the MX chip. So so you have a full tutorial on how to get started, and then you can leverage the example that that Benjamin was doing.
Cool. Thank you.
I'll be taking a save of the chat, and I'll see if I can put up a list of all of the different links that we've got in there. There's heaps of them now, so be worth saving and reproducing somewhere, I think. Thanks for all of those. Any other questions for Benjamin? Silence. You've stunned them into silence.
I'm starving actually. So if folks don't have any more questions, I will just finish by posting a shameless plug to my like the best way to get a hold of me. It might be on Twitter. For those who don't follow me already, just drop me a line anytime, especially if you end up trying some of the RTOS stuff. I'd be happy to hear about what you're going to build and retweet your crazy projects too.
I'm gonna do the same plug. I didn't show the slide at the end, but yeah, I'm doing the same plug. So if you have any questions, always feel free to reach out to us. If you have hardware questions or anywhere from the building end to end, we are both happy to answer for you.
Awesome. I'll be sending a couple of questions. I've got a couple of questions on a bit of work that are quite top level down, actually. So nothing particularly complicated. You'll probably just go, no, doesn't exist. So yeah. Good. There you go then. So yeah, with that then we might as well, being as Benjamin's going to go and eat his arm if he doesn't get off to, what time is it with you there, Benjamin?
20 past 10?
In the morning.
I think yeah. I'm just 1 hour ahead of you guys, I guess.
Oh, okay. Well, there you are then. I see. Yeah, of course. And then it's I don't know, what, 4 o'clock for you or so? I don't know what time it is actually with you there. Must be earlier than that, actually.
It's
I mean, it's 1 p.m., right?
Yeah.
It's 4 with me, 4:23 at the moment.
Oh.
We had someone from
dinner's
Houston
coming soon.
Yeah, it works out quite well. I think GMT or BST as it is now works quite well for most, unless you're in Australia and then it's the middle of the night at the minute. But yeah, I think for most people it works out all right. But yeah, so once again, thank you very much to Pamela and Benjamin for taking the time out of their massively busy schedule at the minute to come and talk tonight. The demos were fantastic, and thank you for all the information and everything you've done so far. And obviously, all the best for Ignite next week.
Yes.
I know that I think me and Pamela and I think Benjamin as well are involved in a couple of sessions over at Ignite as well. In fact, I've just had an invite to go and meet up and find out what's going on. I'm pretty sure that invite tells me it's at 12 o'clock tonight.
It is. But there's going to be an email that I have drafted to tell you that it's going to be recorded, and we're all good.
Future me from tomorrow thanks you for that.
Don't worry. You'll hear my voice again. I'm sorry. In the recording.
Yeah, that's fine.
But yeah. But yeah. I hope everyone reaches out to us and let us know. Give us feedback. Share your projects, as Benjamin said, and thank you so much.
Yeah, thanks, and hopefully we'll see you again. And again, don't forget, next month we've got Davide Zordan and Paul DiCarlo coming along, and there's .NET Knots at the end of the month as well, and podcasts to look at, and you've got to go and follow Benjamin and Pamela on Twitter and get involved with Ignite, and you've got lots to do, all of you people that's still here. So you have a busy couple of days of it. So yeah, thanks very much again, and we'll see you all soon.
All right. Bye. Thanks, everyone. Bye.